Today we are solving the HackerRank C programming challenge called Small Triangles, Large Triangles. We have n triangles. They have the sides A, B, and C. And we have to print them, but before we do that, we have to sort them by their areas from the smallest one to the largest one. It is guaranteed that all the areas are different. We need to use something known as Heron's formula, and we need to calculate this using what they have here. So first we find the value of P, which is A plus B plus C divided by 2. And then we calculate S for the area, which is P times P minus A times P minus B times P minus C. And we need to get the square roots of the results here. So let's say we have 3 triangles. We need to print the sides A, B, and C, but we need to sort them first by their areas in ascending order. So let's look at the header that they've provided for us in this challenge. First, we have some standard headers, but we also have math.h because we need to get the square root function. And then they give us the structure for a triangle. It's a struct. And then here in their main program, they get the value for n, which is the number of triangles that we have in this challenge. They get the value here for this variable using the scanf function. And then here they create a list that is large enough to store n triangles. So you see here that they have the size of a triangle based on the struct here, whatever size it is in memory, and they multiply this by n, and then they allocate memory for n triangles with the malloc function. And this returns a pointer. In this case, it's a triangle pointer, and they store it in the tr pointer here. Then they have this for loop where they collect the values for the sides of all the triangles. So they use the scanf function for the sides A, B, and C for every triangle. Then they call the function that we have to complete in this challenge. This function takes the list of triangle tr as the first argument and the number of triangles as the second argument, which is n right here. Then they loop again through the list to print all the sides of the triangle. And they expect this to print the triangles like this, A, B, and C, but sorted based on their areas. When they are done, we return 0 for the end of the program. So here is how you can solve this challenge. Notice that this is a void function, meaning that it's an in-place algorithm. We don't have to return anything. We have to operate directly on this first parameter. So I've been playing around with different kinds of algorithms, and it was pretty fun. I'm going to remove this comment here, and let's look directly at my C code for the solution. First, I create an array to store the triangle areas. So all the values are going to be floating point numbers, and the size of the array is going to be equal to the size of my triangle list. Then I have 2 other values, P and S. This is to calculate the area of any triangle. They've given us the formula here. So I now have a loop to go through my entire list. I need to get the value of P first for each triangle. And for this, A plus B plus C divided by 2, I'm using this line of code. So for the given triangle at index I get the value for the A side, then the B side, and the C side. I sum them up, and then I divide them by 2. Then I use the value for P at every iteration, and I run this formula for the value of S, and then all of this here is enclosed within the square root function. And whatever value I have, I then store it at the index I inside of this array. If you look here, I don't actually need to truncate anything to an integer because I'm still storing it as a floating point value. So apologies if I need to remove some of my comments here because I was playing around with my code. Now that this array is populated in the same order as my triangles list, I can have a loop, and inside of that loop, I'm going to use the insertion sort algorithm to sort the areas. But whatever swapping I'm doing, any swap operation that I'm performing on my areas array here, I'm going to replicate the same swapping operation on my triangle parameter, my TR parameter, which is this one. So here I'm saying if the current index is lower than the one before it, it means that I need to do some swapping because it's supposed to be in ascending order. So I can use insertion sort. I get my J variable, which starts from I, and then I keep swapping until this condition is false. So as long as J is greater than 0, and I still need to perform some swapping, I'm going to grab my current value at index j, store it inside of temp. Then I'm going to update the value at index j with the one before it, and the one before it is now going to get the value of temp. So this here is how I do the swapping, and whenever I'm doing this swapping, I'm copying the same swapping operation to my triangle parameter. So here I get a temporary variable for the triangle at index j, then I swap it with the one before it, and I update the one before it with what I stored inside of temp tr. And I need to reduce the value of j at every iteration so that I can keep swapping until the current value is in the correct position. Once this is done, this array is going to be sorted in ascending order, and the list of triangles are also going to be sorted in the same order as this array. Now I can run this code. We've passed the sample test case. We can now submit it. It's all C code, and we've passed all the test cases. I think there were 11 of them. And that's it for the solution to the HackerRank C challenge called Small Triangles, Large Triangles. If you like my solution, please subscribe, and I'll see you next time.